Hello champions, how are you all? I hope you all are preparing very well for your board examination. Today in this particular session, we will be covering a very easiest part of your syllabus, that is computational complexity. This particular chapter is actually a very mark fetching chapter. There are some things, there are some less things that you need to understand. After you will be understanding these things perfectly, you will be ready for appearing this kind of questions in the board examination. So let's start. Okay, the first we need to understand the term that is computational complexity. The meaning is very simple. Here I have just typed down and kept over here so that directly you will be able to use these all statements in your examination. Okay, so let's read. So here it says computational complexity is nothing but amount of computing resources. This is the important part. Computing resources. Okay. Computing resources means what? Any physical component or any virtual component of a computer system will be involved for processing, storage, and for communication of the algorithms. Okay, so if I will briefing this, it will be said to be as it is nothing but amount of computing resources needed for an algorithm to run efficiently. So whenever some of the computing resources will be involved for making your algorithm to run efficiently and successfully, we'll be calling that particular thing as computational complexity. Okay, now they are universally divided into two types as mentioned here. One is time complexity, another one is space complexity. By the name also you could easily able to identify. Time complexity means it is talking about time, and here it is space complexity means definitely it will be talking about space. Now let's see. Here it says any particular this particular time complexity will determine the amount of time required for the execution of the algorithm. Okay, whenever an algorithm is written, okay, let me briefly explain you what is algorithm. Whenever a program is written, before that the algorithm of the program is written. Algorithm will help us to understand the flow, how will a program execute. Whenever bigger programs are written, first the algorithm is drawn and the dry run is been taking place. After the programmer will find that yes, I am now successful with the algorithm, then only that particular programmer will start writing the program. And with this time complexity, what will it do? It will determine here. Just a moment. Here, let me cut this. Here it determines. It will our time complexity will determine the amount of time that is required for the execution of our algorithm. So how much time will our algorithm take to execute? That is defined by my time complexity. Okay, now talking about space complexity. See, here I will be talking about space. So it will say me the amount of space, the amount of bytes that will be consumed for the execution of the algorithm. Okay, these are two universal types of complexity. Later on we will be solving many questions based on this. Okay, no need to worry about this. Now there is a very beautiful term that you must be observing in your book, that is big O notation. Okay, this O, usually questions come, what does this O mean as? This O is nothing but omega. What is it signifying? What is it representing? So here is the definition. Omega O is a way to measure the time and space complexity of an algorithm. Okay, whenever you will be writing the time complexity and the space complexity, this omega, that is O, will help us to represent. Means you can say that as whenever we are writing distances, when I will be saying that it is 5, he has traveled 5, you will be confused. What is this all about? I need to say 5 meter or 5 kilometer, right? Physical quantities are given over there with this particular numerical number. So the same will be work over here. Here what happened, whenever our complexity of time will be represented, the big O will be written. and this is the representation of big O. As I have mentioned here, representation of big O. On means O is my omega and n is the time complexity, means n times this particular my algorithm will work. I will be showing you what is this n times what I have right now said you. I will be explaining everything. Just make sure that you watch this particular video till the end. Okay, if you're first time watching this particular video and you're visiting this particular channel, make sure you like to this particular video, subscribe to this particular channel for such insightful content. Okay, now see, I have described over here. Here it says On, where O is the omega and n is the time complexity. So here it says its main use is to compare the best time complexity or space complexity. Okay, so whenever a program is written, if you have written a program and I have written a program, both of it's very, if I will be practical, it's not necessary that both of our program will be accepted by the teacher. Why? Because you must be observing there will be some students in the class who will be doing a particular program or writing the code for a particular question in very smaller steps, where there will be some other students who will be writing the program in a very bulk manner. So there comes this particular complexity. So what will happen? The teacher will start evaluating which of the program consume less time to run and which of the program consume less memory to execute that particular algorithm. And when a teacher will be find that yes, this is the best time complexity program, here the time is least to run this particular program, then the teacher will be saying yes, this is the best program. Okay, and there is a high possibility that lesser the time complexity, lesser will be the space complexity. Okay, most of the places, I'm not talking about all, there are highly many places where you will be finding that lesser the time complexity, lesser will be my space complexity. Okay, see, suppose the time complexity is On here and the other algorithm is On square here, then we can conclude that the first On confuse omega n consumes less time than the further. Okay, if I have written, let me zoom this particular part if it's not visible. Just a moment, I am bringing it down. Now it's fine. Yeah, so here it says that suppose if any of the program you have checked, there you have found that the complexity of one particular algorithm is On and the complexity of another program is On square. So what will you what have you observed from that particular thing? You have concluded that the first On has consumed less time than this particular thing, that is On square. Okay, this was all about our concept, computational complexity, big O notation. So I have brought some other things for you all, that is, let's learn how to calculate complexity, because usually you will be getting questions out of this only. You are getting questions. So here you might be observing I have written a programming question. Okay, this f will be in lowercase. Okay, this f is in lowercase, just consider to be as lowercase, or you can write like this. This is in lowercase. For int I is equal to 1, I is less than equal to 10, this is semicolon, and I plus plus. Now as we know, how many times this program will run? It will run, yes, 1 till 10. That means it will run 10 times. That means the complexity of this program will be O, and this is the number of times. Inside this parenthesis is no magic, there are no some exceptional numbers that are stored. No, only the number of times a loop is executed. Most of the places that is only written. Here you must be observing that the program has run for 10 times. That means number of times here is 10. Number of times is 10. Okay, so see, here there is a very beautiful question that I have observed from the previous set papers and the sample papers. Here it says if 10 is replaced with n, then what will happen? Then the complexity will be obviously omega n, right? If the value is given, so you will be writing the number of times it has executed. If no value is given, suppose instead of an a will be given, suppose it will be replaced with, it is replaced with a, okay, and the other things are same, so we will be saying omega a. That's all. This will be your time complexity. Okay, I hope you have got this. Now talking about another program. Yeah, this is just the code snippet where I have considered only a if condition, conditional statement. See, here I have written, this is again lowercase if x is lesser than is equal to 9, then the Shubham Sharkey class will be printed. Now what will happen over here? So here I have every time said you. Now can you say me how many times this program will work? How many times? Once. Because dear, this is a conditional statement, this is not loop. Conditional statements, yes, this is a conditional statement, but the previous one was loop. That's why we have said this, that it will be working for 10 times. If it is replaced with n, then it will work for n times. But here the question is something different. Here it will only work once because it's a conditional statement. That is why I have written over here, this code performs a single comparison, and if the condition is true, a single print point, that is system.out.println, whatever you are keeping over there, that will be executed. Therefore, the time complexity for this code is constant. What is this constant? Constant is nothing but omega 1. Why omega 1? Because it will work for only one time. Only one time it will work. Did you get this? Yeah, nice. Now talking about another. See, here I have considered a if and also else. So here, if it is asking us to find out the time complexity, the story remains the same, right? Either this will work, either this will work, or this will work. There will be never such situation in which both of them are working. And if at least if any of one of them will work, then what will we call this as? We will be saying it has worked for once, right? It only worked for one time. Are you getting what I'm saying? See, if will execute, else will not execute. And how many times this if will work? Once. Okay, if the condition that is written inside this particular if parenthesis, if this is false, then my else will execute. How many times else is executing? Once. So here as well you will be getting the time complexity as omega 1. Don't be confused. Okay, see, just follow whatever I'm saying, you will be understanding everything very perfectly. Now yes, this is else, he is in lowercase. Okay, here see, very beautiful this program is written. First let me talk about this particular, see, let me talk about the construction of this particular program. Here actually there is a big body. That means if this particular if will be true, if will be true, then here you must be observing this particular thing, this if else will execute. That means if my if is true, okay, then this else will not work, and if my if is false, then else will work. Okay, at first if I will be taking, if my outer condition if will be true, then any of this particular two condition that is retained inside this particular parenthesis will work. And if my if is false, if this is false, then what will happen? My else will execute. Okay, this is the construction of the program. Now let's try and find out the time complexity of this particular thing. So here the constant time complexity, here also it will be 1. You will be thinking, sir, why? See, here what happened, let me break this down. If this will work for once, this will work for once. Okay, if this is true, so what happened, inside the body any one of them will work only once. Either if will work, if the condition of if is false, then my else will work. Okay, so once only. If this particular thing is false, then what will happen, this else will execute, and else is executing once. Else will execute once, right? See, only once this particular whole thing is running. That's why we have considered the time complexity, that is constant, as 1. Okay, yeah. now I have considered another looping, but this time I have considered a nested loop. Yeah, see, very good question. So how to solve this kind of question? A very important, because students usually write correct answer for conditional statements, but for this looping kind of statements they are unaware, they do not understand the logic behind this. Okay, so see dear, so here I'm having n, here I am having n, so this will work for n number of times. Okay, we're talking about this. If you will be observing this particular thing very carefully, you will see that at first my this particular inner loop will work for once, then for the second time two times, because see, as my value of I is 1 here, this j will start from 1 till 1. Okay, so at first 1. If my j of value is 2 for the second time, j will start from 1 and it will reach till 2. So I could say that for the first time it work once, then 2, then 3. Okay, then till it is working for 2 times, then 4 times, then 5 times, this will work. So eventually if we will be taking it till n, okay, till n times this inner loop will work. At the first time only once, for the second time 2 times, 3 times, then the time will come it will work for n times this particular inner loop. So for this we can draw out a formula, n plus 1 divided by 2. Yes, this is which we do. This is nothing but a small maths formula to find out the sum of numbers from 1 to n. So actually here there is a small concept, that is dominant. So whenever you are getting this kind of expression, this kind of complex expression, what you need to do? You need to only keep the dominant ones and ignore the other part. So here, which part is the dominant one? Which part is the dominant one? This part. This part is the dominant one. So here what will be done? Only n will be considered, while the other parts will be ignored. And from this particular outer loop, my n will be considered. So n into n. So n square. So we could say that the time complexity for this particular nested loop is n square. So big O notation, then n square. Okay, this is the time complexity. Yeah, see, this is the reason. Okay, directly the answer will not be omega n square. This is the reason why we have considered n and n, even though I'm having I here. Okay, did you get this? Yeah, very good. Now talking about this particular program. Yeah, another program, very good program this is. So here if you will be observing things very carefully, you will see that my first loop will work till n. And talking about the m loop, every time it will work till m. So how many times this whole nested loop will work? Easy, right? N into m times. Yes or no? So the answer to this will be big O notation, n into m. That's all. This is the answer. If anybody will be asking you time complexity for this, this is how it should be solved. Okay. I've slightly changed this particular question. I have considered that if this particular n will be kept as n and this m will be changed to n, what will happen? The question, there are many questions that come such like this. If my inner loop, see how the statement will be written. If my inner loop is replaced with n, this is my inner loop. If my inner loop is replaced with n, then what is the time complexity? This is my outer loop. And what is my time complexity? Easy. There it was omega n into m. Here m is converted, m is replaced to n, then n into n. Then the answer is omega n square. Very simple, right? Yeah. See, n into n, or you can also keep n square, your wish. Now I have some more concepts for you to explain. See, talking about the complexity, we have been finding complexity, like only time complexity. There are some other term that we need to discuss, that is how many times this complexity are divided. This kind of complexity are divided into two types: best case complexity, worst case complexity. Best case means when it will be taking least time to solve, least time to execute the algorithm. there you will be considering that as best case complexity. Worst case complexity is where most of the time will be consumed. This is the highest time that is consumed to execute a particular program. Okay, so here are some of the analysis that has been kept for my best case and the worst case after this all technique is observed. Okay, so these are just 1 to 2 marks question. That's why I have directly written here best case complexity and the worst case complexity. You can sit and you can just try this out, how to find why the answer was this. Okay, linear search technique. If you could remember linear search technique, what was happening? Suppose there is an array. I will be just briefing this out. Okay, this is 1, 5, 7, 6, 8 and 9. So by using linear search, what happened? This is the searching technique to search a number whether it is present or not. If a user has given any number, so what happened? Every index place that particular number was compared, whether this is equal to the number that is present over here or not, the number that is present here or not. Accordingly, things were used to check. So how many times it was working? It was working n number of times. That's why you could observe here that my worst case is what? Omega n. Because what happened? Here the worst case will be what? The number will be present at the last place. So if my number, worst case scenario, we do talk, right? Whenever we are talking, hey dear, what is the worst case scenario for this particular matter? We do usually say, so here also in our worst case scenario, we are observing that my number that is to be searched is present at the last place. So how many times this particular array will work? N times. This is once, this is second, this is third, fourth, fifth, sixth, and it will run till n. That is why my worst case is what? N here. Now what is the best case? If my number will be present at the first place. Are you getting? If my number will be present at the first place, that means this is the only time when my algorithm will execute for the very least time. Yes or no? That's why I have considered my omega to be omega 1. Yeah, because it will work only for once. If found, then it will be stopped, right? Why will it again search in other places of this particular array? Yeah. Okay. Now talking about the binary search. If you could remember binary search very properly, I told you I will be just briefing you. Numbers will be arranged in a sequence of order, that is ascending or descending. So if I have taken all ascending, okay, I am storing everything in ascending. So if you could remember in binary search, what was happening? A middle number was picked out, then that particular number was used to check with the number that is given. And if a given number is equal to the mid, then the number is found. If a given number is lesser than to the mid, so it will start searching in this particular area. Here also it will be following the same thing. Again, a mid value will be found out, then the things will occur. And if a number was found that is greater than the given number, so what? This is the place where it was found out. So what happened? If you will be observing this particular thing very carefully, here actually it enhances. If you will be considering linear search technique and binary search technique, if I am having crores of data, binary search technique is the best utilization over there. Yes or no? Because see, every of my number will be divided with 2 and it will be only searching for a sub part of the crores of numbers that I am having. Okay, so you can consider this is also this question is also usually asked, which is the best technique to search a character or an element in an array. So every time it is binary search. Now what will be the best case scenario? If my number is found at the middle. Yes, because whenever this question is solved, if you will be looking into into this particular program, the code snippet of this particular program, you will find that first the mid place value is found out. At first the number is checked with mid value, then this all a range of the numbers are changes. So if my number is found at the mid only, so that would be the best case scenario. Are you getting me what I'm saying? Because at first what happened, mid value is found, and when a number is compared with mid value, at that time only the number will be considered that it is found. Then what does it mean? That means it is the best case scenario, that is omega 1, because it has worked for once. But if the number is not at all present at my middle, so it will keep on searching. So when it is keep on searching, that it has found out that the expression is O log n. Okay, why O log n? There is a story behind that. Whenever you will be having a bulk quantities of the number, you will find an expression has been picked out, that is log n. It has been observed that this is how the number of steps increases whenever we will be using binary search and the number is not present at the middle. This is the expression that has been taken up for the worst case. Okay, now talking about the sorting. So for the sorting also the same thing. Here our best case and the worst case remains the same. You will thinking, sir, how? Arey dear, here what happened? I need to sort the numbers, right? So always, every time, if I am having my unsorted numbers, so what will happen? It will sort. And if I am having the sorted numbers as well, so what will happen? It will consume the same time only, right? Because in the previous cases we were searching, if the number was found, then stop that. But here what happened? If my one number is arranged, then it will definitely not depend to my entire process. So in this kind of selection sort kind of technique, you will find that every time what the best case scenario will be same to be worst case scenario, that is omega n square. Okay, now talking about bubble sort. It is very interesting. In bubble sort technique, what happened? The best case could be omega n. Why? Because here, dear, if you will be looking to this particular thing very carefully, you will observe this, that our let me define this bubble sort. Let me give a glimpse of this. Bubble sort means what? The neighbor values are compared and then swapped, checked and swapped, checked and swapped. So the best way would be when it will be working for once. Yes or no? If this particular swapping is done at once, that is for n times, and my numbers are sorted, that means it is the best case scenario. It is the best case. So here it says that it is my best case. Yeah, if the number, see here it is say that if the array is already sorted, then what happened? The neighboring characters will be checked and the loop will stop here, right or no? Yes or no? This is the best case. So what is the best case for the sorting? Best case for any sorting is if my numbers are already arranged. And in bubble sort, as neighboring elements are compared, if every neighboring element will be found that they are in order, either ascending or descending, so you will consider that is the best case, right? But in selection sort, if you could remember the process, something different is happening. What is happening? Let me explain you briefly. One character is picked out. Yeah, no, first of all, what happened done? What is done? The smallest character is found out, and that particular smallest character is exchanged with the first index. Then again, from this particular range, again a smallest value is picked out, and that is replaced with my second index. If these things keep on working, that is the only reason why my best case and the worst case for my selection sort is same. But for bubble sort, what happened? Consecutive pairs are compared or neighboring elements are compared. If my array will be having ordered, if my elements in the array will be ordered, then what happened? It will only work till n times. Okay, and the worst case is what? Omega n square. Okay, and here are some of the common names that are given. So whenever 2n square is you are observing, that means you will be considering that as it is nothing but an exponential term. And whenever you are finding n square, there you will be saying it's a quadratic complexity equation. N cube means cubic, 1 means constant, log means logarithmic. Okay, these are common terms that you need to keep in your mind. Yeah, this is a very good question. Find the worst and the best case complexity for this. Try to find out. Let me see how to do this. Very easy this is. Just pause this particular video and try to find out and compare your answer with me. Yeah, okay. So if you will be observing this particular thing very carefully, this is a different for loop and this is my nested for loop. This is my nested for loop, and this is my only for loop. You must be observing in this entire video, I was explaining everything logically. You need to follow that whenever you are solving this kind of question. Okay. So if I want to find out the time complexity for this, how to solve this kind of questions, as these are separated, separate loop, like you solve them separately only. Okay, so it will work for A times. And talking about this, as we know, B into C. Okay, because this is nested loop. Now if you will be combining them after combination, you will observe that the answer will be omega A plus B into C. Finish. Because this is for that particular loop, this first loop, and this is for my nested loop. That's all. This is the time complexity for this particular question. Okay, now talking about best case and the worst case. Do you feel, well, my best case will be altered with the worst case? No, because what is the worst case or the best case for the loop? It will work for that many times only, na? See, if my x is equal to 1 and x is lesser than is equal to a, okay, so it will work till a times only. And if you will be considering this nested for loop, then you will be observing that it will be working for b into c times only. Okay, could able to get what I am saying right now? Yeah, so that's all for this particular video. If you have watched this video till end, if you learned something valuable, make sure that you like to this particular video, comment to this particular video, and subscribe to this particular channel for such insightful content. Thank you so much. Bye bye.